the floor and the attention, everyone, is yours.
Yeah, thanks a lot, Olaf, for your kind introduction. I'm pleased to speak in this audience. I think there has been quite a lot of introductions already to the topic. I did notice that we talked quite a lot about different challenges. Let's really start talking more about how we can solve them, and I hope I will shed a little bit of light into this topic. So there's no point of introducing microLED technologies. We all know a lot about it. What I want to emphasize here is that this year, I think we all can agree, especially those who have been to Display Week, that the quality of microLED demonstrators has dramatically improved. Yes, people have seen microLED demonstrators 10, 15 years ago, but we've never seen something like is there now. In terms of quality, it's very close to product. There are still other challenges, cost and so on, so I want to talk a little bit about it. I'm also particularly happy that there are advanced demonstrators made with QuustomDot color conversion technology, which also has not been the case. It's only in the last couple of years where we've seen real, very close to product quality demonstrators. So I'm going to talk a little bit about a few challenges and how we believe QuustomDots can help solve these challenges. So reduction of bill of material. I'm going to dive a little bit deeper in that. We believe that by using QuustomDot color conversion, you can dramatically increase the actually efficient use of microLED wafer, increase the area of the wafer you could use. Also eliminating the need for red microLED, while despite a very good progress, it's still a challenging topic. Simplification of the manufacturing process due to decreasing the number of transfer steps or cycles you need. And in general, by adding QuustomDot with their narrow emission line widths, they are efficient color converters. You can increase color volume, efficiency, and then ideally also ecological footprint, which is something that is important for consumers. So we believe we as a component manufacturer, basically, we can help the end application to be more appealing to a customer. So I think we know a lot from companies like Yole or TrendForce about the problems in the cost structure of microLED displays. The majority of costs lays in a cost of microLED chips and then cost of yield and repair. It's really dominated by that. You can think of creative, simple strategies how you could improve that. You can really, we believe, decrease a repair cost dramatically by simply adding more redundancy, adding extra LED chips per subpixel. You can then dramatically reduce the need for repair, but then you end up with having much higher chip cost. How we can still reduce the chip cost? One topic has been extensively discussed today, I think. You can, today and yesterday, you can keep on reducing chip size, increasing substrate size. We've seen great progress on growing GaN on silicon 300 millimeter. We believe that's going to help. But then we also think QuustomDot color conversion can actually help with increasing yield of usable chips. What do we mean here? We all know about wavelength uniformity of the wafers. The problem is that the human eye is very sensitive to minor color shifts. About 2 nanometer is already detectable by a human eye. So increasing the uniformity of typical, again, I think there's a lot of people coming more from EPI who would claim that they have much better numbers than that, and it's very good that there's progress. But it anyway remains really challenging, especially on the larger substrates for growth. Which leads to, of course, obvious challenges. Consequences, you get a display Mura, you need to bin, which basically all contributes to the higher cost. Yield goes down and the cost goes up. So we are suggesting to use QuustomDots. There's no need to explain what it is, I think, in this audience. We are very proud that we are working in a field that has been